Okay, we're going to start lesson 3.14 today with a little notice and wonder. And this is not like a normal notice and wonder because what we're finding here is actually going to be used throughout the rest of the lesson. So make sure that you get this down. I see we have nested triangles. We have a right triangle situation with an altitude drawn to the hypotenuse. So whenever this is the case, what we need to do is we're going to write the equivalent ratios, but first we're going to break these triangles up. So here's how we're going to do that. The first thing we're going to do is we're going to draw the three right triangles. So we'll start with, we have the big one, we have the medium one, and then we have the small one. Okay, those are our three right triangles. What I'm going to do is I'm going to come over here to the big right triangle. The smaller leg is A, the longer leg is B, and the hypotenuse is C. So there's our first right triangle. Our next right triangle is the medium one here in red, and I erase those because I want to do color coding. So here's my medium right triangle in red. This smaller leg is H, the longer leg is Y, and the hypotenuse is B. Then we're going to move on to this smaller right triangle in green. So we'll draw this one. The smaller leg is X. The longer leg is H, and the hypotenuse is A. So what we want to do is we want to write the equivalent ratios for the figure. Now to do that, what we're going to do is when you draw these ratios, what you want to do is you want to pay attention to the shared sides. So notice I have side B in the big right triangle. I also have side B in the medium right triangle. So when I write my ratios, I want to somehow include those two sides. In addition, I have a shared side here, side A, and it's over here, side A. So where else do I have shared sides? I have one more set of shared sides. I have side H down here on the bottom. Oh, that's a bad color. Side H down here on the bottom, and side H over here. So notice that we have shared sides in all these triangles. Now, when we're writing the equivalent ratios, what I want to do first is I want to include side A. So my first ratio, I'll put the A on top. The corresponding side that goes with A is X in the smaller triangle. And that is equal to, now I want to use the A in the smaller triangle as well. So for my bigger right triangle, the hypotenuse is C. The smallest right triangle, my hypotenuse is A. So there is one set of equivalent ratios. Good proportions there. Okay, next one. We're going to do the same thing. This time I want to use side B. So I know I'm going to compare triangle 1 with triangle 2. So I will start with the B on top. The corresponding side is Y. And then I know that I want to use the B in the hypotenuse as well here. So then I'm going to have the hypotenuse of the bigger one on top and the B underneath. And then my last set of ratios that I want to write, have to do with sides H. Okay, so I'm going to use the H in the medium-sized triangle goes with the X, and the Y in the medium-sized triangle goes with the H. Now, if you look at these three proportions, you'll see why I chose those, because I have shared sides in each one of these ratios. Okay, shared sides in each one of these ratios.